All right, so good afternoon, everyone. If all is well, everybody's doing all right. Afternoon. All right, so last class we did 8183. 83 ended in simple interest. So we're doing 84 today, compound interest. That's the only section left in chapter 8. So we'll just do that one and stop right there. So there's 3 sections in chapter 8, 81, 83, 84. Remember, no 82. You're not held responsible for 8.2. All right. So 8.4 compound interest. So here's our compound interest formula. Excuse me. All variables are the same, except we have a new variable. So let's look at those. So A is going to be your total amount or future value. P is your principal or that deposit, that initial payment, initial amount of your loan. R is your rate, which is, don't forget to convert that to decimal. T is your time in years. And N is going to be the number of compounding periods per year. All right. So basically, the time in between the times that the interest is applied to your principal. So we're talking about the number of times interest hits your principal or applied to your principal within a year. And I don't know if I read off the scripture formula or not. So we have P times 1 plus R over N raised to the N times T power. So N times T is an exponent. N times T is an exponent. Now, when it comes to N, the number of compounding periods per year, normally they're not going to give you a number. They're going to give you a keyword that's going to let you know what the number is supposed to be for N. So annually is 1 time per year. Semi-annually is 2. Quarterly N will be 4. Monthly N would be 12. Weekly N would be 52. Then daily is going to be 360, not 365 because of Banker's rule. Scroll up. All right, everybody hold on to blue still. All right, so here we're going to deposit $7,500 in a savings account that has a rate of 6%. The interest rate is compounded monthly. How much money will you have after 5 years? Give you a chance to write that down. All right. So just like any other time I've mentioned, we want to write down the given pieces of information first. So P is going to be 7,500, R 6%, which is 0.06, N compounded monthly. So that means N is going to be 12, and then T is going to be 5 years. So now we plug it into the formula. Formula is P times 1 plus R over N raised to the N times T power. So that'd be 7,500 times 1 plus 0.06 divided by 12 raised to the 12 times 5. Now, depending on the type of calculator you have, a lot of calculators, you can just put that in just like that, and you'll get the answer. Notice, not expecting you to do any handwork here. I went from the formula right down to the answer of 10,116.38, or in other words, 38 cents. Always make sure we round it to the hundredths place because we're dealing with money. If you don't have a calculator that can put the figure in like this, then you may have to do it in pieces. In other words, 12 times 5 is 60. Divide this, add it to 1, raise it to the 60th power, then multiply by 7,500. So basically you have to find the answer by using your order of operations. If you have any questions about your calculator, then most definitely you can either come to class, bring your calculator to office hours, or set up a Zoom session outside of office hours where we can look at your calculator and make sure you're good with operating. But you will need to make sure you know how to use your calculator, because you do not want to raise something to the 60th power by hand. All right. Any problems before we go to B? Okay. B, find the interest after 5 years. So your interest is always going to be the future value minus the present, or your principal. And so it's A minus P. So A was 10,116.38 minus the 7,500, which was your original amount. And that gives us 2616.38. As far as how much interest was earned in the 5 years. All right, any questions? All right. The next formula is compounders. I said compounders. Continuous compounding. A is equal to P e to the RT. So RT are exponents. E is not a value that we're going to be plugging in values for. Is actually the exponential function. So it's not a just regular variable. It's actually an application. It's a function. So E should be somewhere in your scientific calculator. So that's P times E to the RT. All right. And continuous compounding is different than compounding daily. Those are two different things. So like I said, the key word for continuous compound that continuous compounding gives you, tells you that you have to use this formula, which is a different formula altogether. Anybody holding on to that formula? All right. So you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first account pays 7% per year compounded monthly. The second account pays 6.85% per year compounded continuously, which is the better investment. So I give you a chance to write that down. All right. So let's look at the first account. Doing that in purple. So write down the given pieces of information first for the first account. Principal is 8,000. Rate is 7%, 0.07. Time is 6 years. And then we're looking at monthly. So N is equal to 12. And so this is our formula right here, plugging it in accordingly. 8,000 times 1 plus 0.07 over 12 raised to the 12 times 6 power. Multiplying that out, well, performing the calculations in your formula gives you 12,160.84. All right, next one. So second account, $8,000 for your principal. You know, that's what we had initially. And we still have 6 years that we're trying to figure out how much we were earning. But our rate is going to be 6.85%. And then it's compounding continuously. So that means we have to use this formula right here. P to the E, P times E to the RT, excuse me. And so it's 8,000 times E. Notice E is still there. And raised to the 0.0685 times 6. So it gives us 12,666 and 60 cents. So conclusion, the first account at 7% monthly compounded is the better investment. So that's the one that gave us the more money. All right, problems, any problems? All right, next one is calculating present value. So notice this is the same formula that we had when we were talking about when we introduced compounding, compounding interest. I can get it out. It's just that we solved it for P instead of having A on one side by itself. So if I want to calculate the amount of money that I would have to deposit in order to get a future value amount, that's when I would use this relationship right here. All right, anybody holding on to the red? All right, so how much money should be deposited today? Let's just know we're looking at present value. How much should be deposited today in an account that earns 6% compounded monthly so that it will accumulate to $20,000 in 5 years? All right. So looking at our givens, P this time is what we do not know. R 6%, T is 5 years, N is monthly, so it's 12, and then we have 20,000 for A. This time A was given as at 20,000. Mhm. Looking into the formula. So that's 20,000, which is A over 1 plus 0.06 over 12, raised to the 12 times 5. And that'll give us 14,827.4439. So notice the purple statement, you always round present value up. So even though if we were to round this and it doesn't tell us to round up because that 3, let's say you can leave it at 44.44, but we have to give an account for this 39 back here. And if I were to truncate this off and leave it at 0.44, then I will not earn the 20,000 that I need. So I need to round up in order to give an account for this back piece. So you always round, whenever you're doing present value, you always round up, always round up. Mhm. Any problems, any problems? Got one more thing to talk about. Oh, charger. All right, last thing that we'll talk about today. Is anybody still holding on to the last, the purple and red? Anybody? Okay. Effective annual yield or effective rate is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. Mhm. Here's the formula. Y is equal to 1 plus R over N raised to the nth power minus 1. And notice that the result should be converted to a percent. All right, let's try it out. The passbook savings account has a rate of 5%. The interest is compounded daily. Find the effective annual yield. So if you look at the formula, all we need is the rate and the number of times it's compounded per year. So our rate is 5% and it's compounded daily. So daily means 360 for N. All right, so we plug in our values. That's 1 plus 0.05 divided by 360, raised to the 360th power, minus 1. Plug that in the calculator, get 0.0513, then convert it to a percentage, 5.13%. Questions, questions, questions. Make sure we're all right. So that's it for 8.3 or 8.4, excuse me. Over here in the circle, I was just emphasizing what's going to be on test 2. So we're not ready for test 2 yet. We're just throwing it out there so you know what going to be on it. Give you a heads up. Test 2 is 818384, and then 919293. All right. So let's talk about due dates. Want to make sure everybody done copying them. Good, 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 good. All right, so next class, we're going to do 91, 92, and 93. More than likely, I'll be able to do all of them in one sitting because all they're doing is conversion. A lot of it is the same stuff. But I'm not going to hold you accountable for that on this Sunday. Remember, this Sunday is your first due date, which is the 5th week grading period. So when it turns 11:59, when it goes to midnight, so 11:59, it will turn to midnight. Once it turns midnight, go into 2021, then it will cut you out if you're in the middle of an assignment. So don't play around with that 11:59. So I will not include chapter 9 in that because we will just be hitting chapter 9 next class. But this is what is expected for you, of you, come Sunday. It's chapter 6, chapter 7, and chapter 8 homework, and then that test 1, which is just on chapter 6 and 7. Okay. So questions on that, what's due on chapter on Sunday. I'm going to change the due date. Once again, chapter 9 is not going to be a part of that block of work that I will expect you to have completed. It'll be 6, 7, 8, and don't forget that first test, which was only on 6 and 7. Any questions, concerns? Everybody good? Straight. Now, also let me say this. If you don't get something completed by the 20th, it's not the end of the world. All you have to do is ask for an extension. It's not that big a deal. But I do have to have these markers out here in order for me to put an assessment out there for you. Like I said, it's 5th week, 10th week, and then the one that cannot be moved is the final grading submission. But if you don't get, let's say if you were to get a D on 5th week grading, all you have to do is ask for an extension and it will be granted. It's not that big a deal. But that's just where you stood at that moment. So before we close out, questions? Everybody good on what I said? Okay. So that's it for chapter 8. Because it's chapter 8, I'm not going to push and jump into another chapter, try to let you breathe for a second. And so we'll pause right here. Next class, we'll get into chapter 9 and we'll go from there. All right, so you guys have a good one, be safe, and I will see you next class.